Welcome back, everybody. Short raise of hands, who has been here when Damian lectured us about what a platform actually is? Not that many people? Okay. The question was back then, well, we know what it is, but actually, how do we build one? Our next speaker is actually going to tell us how we build platforms, especially cloud-native platforms for small teams in a GitOps automated way. He has more than 10 years of experience as an architect and as a software developer. He is the lead DevOps engineer at Open Research. Please give us a warm welcome for our next speaker. I forgot your name, I'm sorry.
Hi, my name is Velimir Iveljic. I'm a DevOps lead and system architect at Open Research GmbH. It's a consultancy and a product company based here in Vienna. And today I want to share with you our path from basically having, your normal infrastructure and deployment stuff to a cloud-native platform that's managed by a very small team of SREs and operations people. And I would also then like to show you or try to demonstrate the principles that maybe you can use in your own organization to achieve this. So first off, the problems that we kind of encountered right from the start were these three. First one was cost escalation, because if you want to do this in a big cloud provider like AWS, Azure, or Google, the costs kind of just like escalate overnight, and it's hard to justify this to the management or the organization. Second problem is the lock-in. Like you build your platform in AWS, you want to move somewhere else because either costs or whatever reason you need to do it, or your presentation died. Here we go. Maybe the cable. I'm sorry. You're locked in now because you're already using some of the side services from this cloud platform, and it's very hard in practice to kind of move somewhere else. And third problem is the operational toil that kind of like, if you even decide to go away from a big cloud, like how do you then do this with a very small team if you're a small organization and you don't have the budget for it? Bringing us to the small team struggle, which basically in our context meant like our budget is tight, our tooling is kind of intertwined and doesn't work, like the presentation. I'm sorry. You don't want to go into a blocked cloud and be forced to stay there forever. And the worst thing is like you don't really have the time to build all this thing up. I'm very sorry. Yeah. Okay. Yeah, you just don't have the time. Like you have 2-3 people maybe, and like building up infrastructure is generally hard. But now you have to like maintain all of this if you go this path, etc., etc., etc. So, in any case, like we had experience in like building up on-prem infrastructure and like trying to automate stuff before. So we decided to go for this, we called it affordability pivot, where we like decided, okay, even though we have some things in the cloud, in like AWS, for example, which is where we host some of our projects, we decided like, let's pivot to commodity compute and choose more control and cost cuts instead of being more comfortable and having all these like things done for you in general. So we came up with a very simple architecture, as you can see, and it's nothing special, but we strived to aim for automation as our main helper in all of this. Because without automation, your team is just going to have different kind of struggles. So maintaining each system manually, et cetera, et cetera, et cetera. So what we did, we decided to go with Hetzner Cloud because we also based in Europe and we didn't want to like stray away too far away from home. And for other reasons, Hetzner gave us like a very good base for this because they offer community compute like cloud VMs, but you can maintain almost all the rest around it with APIs. So meaning you can just use Terraform provider from them and then start up your whole infrastructure. And then when we had that, we decided, okay, how do we host Kubernetes on it? So we went with Talos Linux. I don't know who of you here uses it. A few people, cool. We find it to be awesome because this is also like a Kubernetes Linux distribution that basically just boots up into Kubernetes. So you don't have any overhead of maintaining the operating system. There's no shell on it or anything. You steer everything and configure with APIs. Again, you can just use Terraform for this or write your own tooling, which we kind of did. I'll come to that later. The second layer of this is, of course, the control plane, which in our case means you have your Kubernetes, you have a GitOps tool. For us, we chose to go with Flux CD because it's the most flexible tool to structure the platform usage the way we do it. And also for us, it's very important that we have Kubernetes secrets that live in it, storage somewhere else outside. So in a case that you want to migrate or move, it's easier to do. And also in case of disaster recovery, which I will cover also a bit later, that you are able to do a quick backup and restore of all of your secrets. Because most of your workloads demand some kind of secrets to start up and move around. And the last layer is basically your normal workloads and some of the automation that you're going to do in this cluster because, again, this is the main focus for us in this whole story in order to offload repetitive tasks and things like that. Of course, we use the GitOps approach. So everything that we have to build the platform is written in Git and nothing that happens inside happens outside of it. So if it's in the cluster, if it's running there, it's written in Git, and you can safely rebuild it afterwards. And you also control the flow of deployments and everything else. But one of the biggest points in doing this was actually a cultural shift in the company, meaning that we basically decentralized the deployments and we changed the team's topology to include the developers in this process, like in them using actually the platform. Being a small organization, this is maybe easier because we were able to organize internal trainings, explain to people why this is a good thing for them, explain them how they can deploy their applications, help them migrate initially. And then basically each of the development teams got their own Git repository where they have their Flux definitions, customized, whatever. And they're then able to maintain the application, deploy the application, take care of the manifests, scale it even if they need bigger stuff, like, I don't know, increase their replicas, storage, databases, etc. Which left our team, and this is very essential for us, our operations team, to concentrate on the platform, building the platform, maintaining the cluster, scaling it if necessary, and building basically the foundation of the infrastructure. This enabled us then to build up some tools that helped us reduce manual toil on the team. So, for example, while building the platform, we used a bunch of open source stuff because it's there, it works good, why not use it? However, some things are not available off the shelf, at least not, let's say, for free, or it's not open source, etc. And this is where we felt this shift in organizational structure, where our team now has a bit more time, so we decided, okay, let's invest this time to solve these problems alone. Main things that we missed was based in security, because now you're in someone else's cloud, like your storage is there, your workloads work there, and you want to make sure that your data is encrypted at rest, So being able to do this in a virtual machine somewhere using Linux, you can either manually type in the full disk encryption password after the system boots up, but this then makes the upgrades harder, makes everything else flaky. So we built like this KMS proxy that Talos Linux can use to automate the boot process and still be able to use full disk encryption. This tool basically just implements the Talos Linux KMS client and forwards basically this request to a KMS server in the background. In our case, this is AWS, but it can be extended for something else. Second tool that we built was to make it easier for us to export and import the Kubernetes secrets from our Vault cluster. So we use Vault as a secret store, which is then embedded with Vault operator in the Kubernetes. And the secrets are in Vault, but they get synced into Kubernetes. So at any given time, you can use this tool, for example, to export the secrets. They get exported in an encrypted manner. We use age encryption to store them on disk. And later on, if something happens, you overwrite secrets, you remove them accidentally, etc., you can just use this tool to load this back from backup. This tool can run either in a daemon mode, like backing up constantly, or you can just use it as a CLI. Both of these tools we open source today. So at the end of the presentation, I will give you links. So if you're interested or you can use this, you can freely then download them. And this is one of our ways to also contribute back to the community, because we use a bunch of open source stuff. So we thought, like, now that we have time and we're solving these problems, let's give something back to everybody else. Good. So the design of the whole platform was based on the concept, OK, what if everything goes down? Like, I don't know, stuff gets deleted, Hetzner server dies, you cannot recover your data, etc. Of course, you panic first. But considering that you now have everything in GitOps, everything's written down in your Git repository, you can then just use the tooling you did to initially start up the platform to deploy it again. So use Terraform to deploy your cloud infrastructure, Talos Linux, your CSI, whatever storage. You put Flux on it. You install Vault, which is also done through Terraform automatically. So our scripts, for example, we start Terraform, and after, I don't know, half an hour to an hour, depending on how much we have, everything's booted up, and you have a base platform or a Kubernetes system to work with. Second part would be to then reload the Vault store, because every workload needs secrets to start up. We already know this. And third is Flux will then start picking up deployments, load your database backups. For example, if you use cloud-native PostgreSQL, like this is all just configured in Flux, in Git. So next time it starts, it's just going to pick it up, take the secrets, download the backups, load the data, and start your application. And in this matter, like you recovered your platform basically from scratch, which sometimes took us days to do, and now it can just be under 2 hours, depending on which cluster we're restoring. So this was kind of amazing for us. And coming kind of to a conclusion, like, so what does this mean? Like, what are the metrics that we kind of can extract from this? So for us, on a single project in AWS without a platform, we were paying for like around 1K per month to just host some applications, the backend, front end, use the database, load balancers there, etc. In Hetzner, with this cloud compute from them, we built up the whole platform for around 300 euros. And So this is like a 70% less cost, which is huge for us, huge. But the kicker is like you can host like 3 to 4 more applications or projects that cost 1K in AWS in the same platform. So it's not just 70%, it's 70% times 3 or 4. And this kind of also encouraged us to build these kind of like mini platforms where we have like clients that, because of compliance, they cannot run in the same cluster as a different customer. So we're just able to use this infrastructure and this concept to spin up different clusters and run either one customer or 2 customers or our own internal product on it and have different instances for very, very cheap money and time because you already automated this. And the second big gain that we got is we reduced boring crap, to say, immensely in our operations team. So now we can invest like almost 70% of our time thinking of how we can improve this, how we can test it out better, like increase observability and experiment with new technologies that will bring us to the future and enable us to scale this a bit more and build new automation tools. So for example, another tool that we built that we will probably open source very soon is automatic upgrades of the Talos Linux. Whoever used it knows it's not hard to do on a CLI, but I don't really want to like track when's the new version out and like go there and do this, and then you have 15 nodes, you have to run this command line on them all the time. So we built like a Talos operator, and it was easy because Talos already has an API interface. So we built a Go operator that just checks Git for new versions. First does this in a test environment. If this passes, then we enable a flag, and every other cluster is then enabled to pick up the upgrades, and then does a rolling upgrade on the cluster. And this is like amazing. And this work will just continue. Like we will now start investing time into doing horizontal scaling with this, also in an automated manner, because now we have the time for all of this. So yeah, that's mostly it. I didn't want to go into super details because everybody has their use case, how they need to do this. We just wanted to show you that it is possible, and if you shift focus from basically doing manual operations and maintaining deployments, etc., if you include your development team in this process of using this and seeing this whole thing as an ecosystem or a platform, you gain more time and you can do more automation and improve it down the line. And you can also have some time to build new tools that you can maybe share with the community. So it's basically affordable design, automation-driven operations, and empowering the team is what it's all about for us. These are the links for the 2 tools that I mentioned. We published them today. They're free to use. The license is open. We use MIT license, so do with it what you want. And we will try to maintain this in the future and improve it if there's a need. That's all. Thanks.
All right, so we still have a lot of time. Do we have any questions? Yes, 1, 2, 3. Yes, lots of questions.
Hey, thanks for the awesome talk. Just a question I wondered. I'm a fan of Hetzner myself, and I was wondering if you were using their cloud offering or their bare metal service or a mix of both, and were you using different regions?
Yeah, so all 3 basically depends on the project. Like we have clusters where we just spin up the VMs and use it like this. This is where the KMS stuff was very useful because we were able to still utilize the cheap offering of cloud and secure our data. We have a bare metal server that's running like Talos Linux. It's mostly for experimentation now. And we have one also where we combine them and where we just connected the Talos Linux nodes through the vSwitch. And yes, we also use zones. You need to be careful though, like if the zones are too far away, your cluster might not be behaving very well.
Yeah, I know they have like 2 in Germany that are very close together.
Yeah.
So it's not really a geological redundant. And then the one in Helsinki.
Yeah.
I used both, and then there was the problem where, I don't know, Russia or whoever, they cut like the cable in the East Sea, and then suddenly the latency in the cluster spiked to incredible values. So
Wow.
yeah,
That was probably an interesting thing to deal with. Yeah, but generally we can recommend Hetzner. It's a super nice hosting provider. It's European.
Hi, just a remark. We just went to deploying Talos on the bare metal Hetzner infrastructure, and I wrote 2 tools which are called to Talos to get the bare metal machine in the rescue mode to Talos basically, and Hobot, like Hetzner robot as a Golang CLI to just get these machines into recovery and restart them and do stuff. So in case you're interested in in
super nice.
This kind of infrastructure, maybe we could have a talk.
For sure. Thanks for sharing.
Are you using autoscaling? And if so, how are you dealing with the problem that at Hetzner sometimes not all instances are available?
Not yet. This is something that we want to extend our Talos operator that's still internal to do. Our idea currently is to ask their API if the servers are available and then try it, but we didn't really, we didn't still invest enough time in it. But they have an API endpoint where you can ask if this server type is available, and then you can start it up. Otherwise, whatever you're using to deploy the machine will just error out in a weird way. And also, like to demonstrate this, there's I forgot the website name. Somebody built a tool, and there's a public-facing website where you can just check the availability of the servers. So it's not from Hetzner, but on Reddit, their official support is advertising this as like, check here maybe, you know.
Thank you.
Just super funny, but it's a nice tool, so yeah. I forgot the name.
I think we had some further questions on this side, yeah. Okay.
Thank you for the talk. Just a simple question about the part where the cluster situation is down. And I didn't understand the part with the secrets, because usually workloads needs a prerequisite secrets that are there, right? But I saw the direction that you encrypt, export, send it to Vault, and the operator sync it to the cluster, right?
Yeah, so our concept is like when we rebuild the infrastructure, we're also using Terraform to like tie in some other stuff from cloud providers. For example, we use Azure for OIDC, etc. So in case of a new cluster, we will just rebuild all of this and inject the secrets through Terraform then. So everything's ready until Vault comes in. And when Vault is up, we then load the secrets. And then after that, like your workloads will probably start failing because they don't have the secrets, but it will just recover after the secrets are.
My question was more about where do you back up those stuff in?
So this tool has an option to back up to a S3 bucket somewhere, but because they're encrypted with a private key, like you can just store them wherever you want. So that, like, we made sure that we keep it, you know, in a good way. And maybe, like, you can also export them to a local disk if you want. Like, it's however you want to use it.
Thank you.
Thanks for the presentation. It was great. One of the questions that I had was with the KMS proxy. So if it's talking to AWS, it's going to need some credentials or authentication to Bootstrap.
So
How do you handle that?
Yeah, the way we do it now, we start up another VM basically that we use for different things also to like, it's like a breakout to our private network VPN through WireGuard. And we use this server, like we call it a management node, that's right next to the cluster. And we have network policies that enable all the other machines to talk to it on an HTTPS. So it's kind of like you need to keep it close. And on this machine, you, of course, then have AWS credentials or whatever your KMS proxy behind it is. Like we plan to extend it to at least use another Vault instance, for example, to do the KMS decryption. Because Vault has this like in-flight decryption capability, encryption and decryption capabilities, which is a cheap thing to implement, but like enables you to have like a completely offline deployment, for example.
Cool, thank you.
You're welcome.
Any other questions? And done. All right. Thanks for your talk. Big round of applause. I'll see you back in half an hour here.